In this course, we consider only two types of absolute value inequalities. First, let's look at the inequality the absolute value of x is less than or equal to 3. Using the geometrical interpretation of the absolute value, we get that we are looking for numbers on the real number line that are at most 3 units away from 0. Note that negative 3 and 3 are the numbers that are exactly 3 units away from 0. So we have the following picture. Negative 3 and 3 are the points that are exactly distance 3 away from 0, and we are looking for all the points whose distance to 0 is at most 3. So we are looking for the numbers between negative 3 and 3. Hence, the inequality absolute value of x is less than or equal to 3 is equivalent to the compound inequality negative 3 is less than or equal to x is less than or equal to 3. Next, let's look at the inequality the absolute value of x is greater than 3. Using the geometrical interpretation of the absolute value, we get that we are looking for numbers on the real number line that are more than 3 units away from 0. Note that negative 3 and 3 are the numbers that are exactly 3 units away from 0. We get the following picture. Negative 3 and 3 are the points whose distance to 0 is exactly 3. We are looking for the numbers whose distance to 0 is more than 3. So we are looking for the numbers that are to the left of negative 3 or to the right of 3. Hence, the inequality the absolute value of x is greater than 3 is equivalent to the compound inequality x is less than negative 3 or x is greater than 3. We can generalize this and to get a strategy on how to rewrite absolute value inequalities. If a is a positive number, then the inequality absolute value of x is less than or equal to a is equivalent to the compound inequality negative a is less than or equal to x is less than or equal to a. The inequality the absolute value of x is greater than or equal to a is equivalent to the compound inequality x is less than or equal to negative a or x is greater than or equal to a. Similar rules are true for less than and greater than. Let's illustrate this with the examples on page 17. First example, solve the inequality absolute value of 9 minus 2x minus 2 is less than 1. We use the basic strategy. So first, we isolate the absolute value of x, of 9 minus 2x. We move 2 to the right hand side by adding 2 to both sides and simplifying. Next, we rewrite the inequality with absolute values as a compound inequality. Since the inequality is less than 3, we get the compound inequality negative 3 is less than 9 minus 2x is less than 3. Now we solve the compound inequality. We isolate x by subtracting 9 from all sides and simplifying. Next, we divide all sides by negative 2. Remember, when we divide the sides of an inequality by a negative number, we need to change the inequality sign. So we get 6 is greater than x is greater than 3. That means that the solution set is the interval of the numbers between 3 and 6. Second example. Solve the inequality the absolute value of 3x minus 1 is greater than or equal to 5. We use the basic strategy and we rewrite the inequality containing an absolute value as a compound inequality. Since the inequality is greater than or equal to 5, we get a compound inequality with an OR. 3x minus 1 is less than or equal to negative 5, or 3x minus 1 is greater than or equal to 5. Now we solve the compound inequality. We move the 1 to the right hand side by adding 1 to both sides and simplifying. Next, we divide both sides by 3. and we find x is less than or equal to negative 4 over 3, or x is greater than or equal to 2. In interval notation, we will have a union. The interval negative infinity negative 4 over 3 union the interval to infinity.